Take it away, Bryan.
Good evening. How's everybody doing? Waiting for snow. That's probably too dark. Yeah. You don't have to if you can't get them down. I will try to stay by the microphone. I have a bit of motion attention disorder, so I'll try to stay by the podium. What I want to do tonight is do two things. One is give you an update on where we're at with the shoreline change maps for Washington County. As Teresa mentioned, these are mostly funded by HUD, a little bit by Bays River's Watershed Coordination Team, but also talk about this very loaded idea of projecting future shoreline change as a planning tool, as to help identify areas that are potentially at risk from erosion in various shoreline change rate scenarios. Okay. So the shoreline change maps we've talked about at prior beach SAMP stakeholder meetings, including this past summer. We've completed largely, meaning I'm just pull puppet strings, largely Rob Hollis, working with Rachel Henderson, do most of the actual work, along with a cast of students and undergraduates that move labels around for us. But we've created 45 new shoreline change maps that range from Napatree up to Potawatomi in North Kingstown, encompassing all of Washington County except Block Island. We're working on Block Island, but we didn't have HUD funding for that, so we'll get back to that soon. These new maps differ from the old maps. Not only are they 10 years more recent, we go up to 2014. The last maps that were on the CRMC website ended at 2003. We're also encompassing more shorelines, which picks up some of the variability that wasn't seen when we calculated using only 1939 and 2014. And overall, the trends stay about the same, but in some areas, particularly around the breachways, there is a better understanding now, or a better depiction of the actual processes going on since those breachways were installed now 5 or 6 decades ago. So these include shorelines from the 60s, the 1950s, as well as two from the 2000s. Okay. These are available right now for review. They're on the Beach SAMP website or linked to the CRMC website. There are 4 maps from the Narrow River that were created specifically for this project for inside the Narrow River. They're not on the map, but they are in the list. So I encourage you to go take a look if you're interested. Jim at CRMC is in the process of getting these updated as the shoreline change maps for CRMC policy, and we'll be working on that in the next few weeks. But mostly what I want to talk tonight is kind of our next step, which is to create a planning horizon. And it really came out of this figure. We made this just because we were interested, particularly in South Kingston Town Beach, a long time ago. We looked at it and said, well, let's project shoreline into the future using the current rates of shoreline change. What would it look like? And did they move the pavilion back far enough was one of the first questions we wanted to talk about down there. Answer is, yeah, maybe. The problem is this is actually a really loaded question when you get into the science. And so if you can't see it, there's a big limb right here I'm actually standing on right now. This is not something we actually see done a lot, at least on these kind of time frames. And so what we're really trying to do is make some kind of prediction of future shoreline change. And what makes me uncomfortable is putting a single line out there and saying, here's exactly where the shoreline is going to be in exactly this many years. So what we're really doing is creating overlays of where we think the shoreline could be using both historic and a couple of other rates we'll touch on. This is not a particularly new idea, at least in the sense of projecting this into the future. As soon as people figured out how to do shoreline change mapping in a very quantitative way, they said, hey, let's multiply it into the future and figure out what it would look like. So this is a pretty standard approach. If you have a historic rate of shoreline change of 1 meter, you want to know what it looks like in 50 years, you add 50 meters to your present shoreline location. The problem with this is, of course, we're facing a new paradigm of the potential for accelerated sea level rise. And to be honest, I don't think we as geologists have a great handle on what that's actually going to look like on the shoreline, particularly in terms of barriers. There's a lot of very scary literature out there, and I don't mean scary in the sense of being wrong. I mean scary in the sense that there are places where there may not be barriers in the future. Okay? At the other end is a more model-based approach where you take the processes involved and you incorporate not just the historical, but also the physical characteristics and models of beach evolution. And so Massachusetts presented this in a report. They looked out 10 years, which is a good horizon to be thinking about. They did something called a Kalman filter on that. But 10 years wasn't quite long enough for the beach SAMP process. We're really trying to guide development in the decadal to century scale. So we needed something in between. We are projecting to the same time horizons as the storm tool scenarios, namely 1 foot, 3 feet, and 7 feet by 2100. Again, I'd point to 7 feet is on the upper end of NOAA's projection. That's not a particularly alarmist number. That's based on their projections. So what we're doing is actually looking at kind of a modified statistical approach. We're doing a little bit of the column A and a tiny bit of column B. The goal here is to create a planning document and some overlays. We're not rerunning an entire sediment transport model for the entire South Shore. There's a lot of work being done that we may be getting to that pretty soon being in years, but we're not there yet, at least for our understanding of the South Shore. So we are going to look at the historic rate. So if you don't believe any of the sea level rise stuff, you don't believe anything I'm going to talk about tonight or anybody else will talk about, this projects what would happen if the status quo continues for the next 86 years. We take the historic rate of shoreline change. We put a little bit in there based on the shoreline change mapping. This adds just a couple of meters to the projections just to cover what little uncertainty we can quantify here. And then we're also looking at rates of shoreline change that increase exponentially. And we picked exponential because, of course, that's what our sea level curves look like. And so we're doing this under both a low scenario, which doubles the rate of shoreline change by 2100, and a high scenario, which by the time we get to 1 meter of sea level rise is increasing it by 2 or 2.5 times the present rate. And this is loosely based on a couple of different modeling studies where people have looked at the amount of shoreline change under different sea level rise scenarios, not from southern New England. Anderson's from Hawaii, and Laura Moore's worked in not just the Gulf, but also the Outer Banks. So this isn't numbers plucked out of thin air. We did a pretty thorough review and tried to come up with some reasonable numbers to project out. This is actually a really controversial topic within the scientific literature, though, because there's a lot of debate about how important each of these different parameters is. How important are storms? How important is sea level rise? How important is the geologic framework that the barriers are built on? So this is a complicated topic, and there's a lot of debate still about whether storms drive or sea level rise drive shoreline change. Storms. But we'll consider that still being a debate. For our purposes tonight, Occam's razor suggests that as sea level goes up, we're probably going to see higher rates of shoreline change. Right? Basically, even if storms drive the bus, every time sea level rises a little bit relative to your bluff or your barrier, you're now allowing the storms to act a little bit higher. And in particular in the barriers, they'll be overwashed a lot more frequently as the rate of sea level rise increases. So Occam's razor, of course, if you hear hooves, don't think zebras, think horses, and of course, don't think about a zorse. Didn't know actually what a zorse was until I Googled a picture of a zebra and a horse and got that. So what do these rates of shoreline change look like? Well, if we use the historic rate, of course, we see no change. If we started, where's the famous GSO pointer? If we started at 1 meter, by the time we get to the end of the century, we're still at 1 meter of shoreline change. Under the exponential low scenario, we double that rate. You'd expect to see us at 2 meters by 2100. And the exponential high, we're up to 2.5 times, or roughly 2 times by 2053 or 2054, something like that. So it gets to be a pretty large number by the end of the century. We'll put that in some context at the end as best I can. So this works, again, as I described with historical. We take our historic rate of shoreline change, and that's a nice simple model. It treated 75 meters in 75 years. Gives us an annualized rate of 1 meter per year. So if we wanted to go out to 2065, which would be 51 years, we add a little bit because of the uncertainty, those gray bars around our shoreline positions. Again, this doesn't add a lot to our projections, but it makes me sleep a little bit better at night. If we want to look at an exponential change, it's a little bit different. And this is for the same rate of shoreline change going out to 2065 under exponential low or exponential high. And the further out you get on an exponential curve, you'll see more difference or more spread between these shoreline positions. We were looking at this in the lab one day, and we had these nice red bands along the shoreline that were projecting an overlay of where the shoreline might be at a certain time. And Rob Hollis, my colleague at the Rhode Island Geological Survey, said, yeah, that's nice, but people are going to think they could build right up against that red line, and that doesn't look that different in many cases than what you see presently. And so we came to the conclusion that we needed to add a little bit more to these projections. And namely, we had to put something that depicted the current coastal regulatory setback, which for CRMC, for residential properties in Rhode Island, is 30 times the annual erosion rate from the coastal feature on a barrier that would be from the crest of the foredune. And so we're attempting to display that as well. The challenge becomes, under the exponential scenarios, the rate of shoreline changes from that initial rate. So all of the setbacks are tied to whatever the projected rate of erosion would be in that year, say 2065. What does this look like? Well, I'll show you some draft figures. This is going to start in Misquamicut, and I'm saying draft, and I'm also saying don't worry too much about where the lines exactly are. We're in the process of editing and cleaning and checking these overlays over, largely assisted by Emily Petrolia from the Marine Affairs Department here in our lab working in the GIS. So for something like Misquamicut, if I wanted to look at, say, 2040 with the historical rate of shoreline change, the yellow area on all of these figures is essentially the distance between the high tide line and the coastal feature. This is one of a lot of assumptions we have to make in these projections, but it assumes that the barriers in the headlands still look roughly like the barriers in headlands today, meaning we have a foredune, we have an edge of the bluff, the beach width and the berm width are about the same as we see today. So on all of these, you see three colors. Red is the projection of where the shoreline could be. Yellow is where the controlling coastal feature will have migrated to. Again, think of that as the crest of the dune. And the orange is the setback zone. So in this scenario, you would not be able to build in the orange zone. You would be building up to it, which again, in this one doesn't look all that bad if you live on that part of the Misquamicut barrier. If we go up to 2100 at a historical rate, you're now building basically across Atlantic Avenue, at least in part. The rates here are a little bit low, or they seem a little bit low compared to the other barriers. This is our most monkeyed around with shoreline on the South Shore, not just in terms of small scale and medium scale replenishment, but also construction of, at least in the past, small shoreline protection structures along the dune. The same area with, say, a 2065 scenario for exponential high. Now we've increased the rate. We're actually across Atlantic Avenue. And if we go up to 2100 now, we're building back in the present marsh. And now that looks deceiving because, of course, in that kind of time frame, we'll have seen likely at least one significant storm event, if not more. We'll have seen overwash. We'll have seen migration of the barriers. You'd be building then on essentially a washover fan back there in all likelihood. The Matunic area, it doesn't take a lot of exaggeration to actually show a lot of erosion here. This is the highest rate of erosion on the south coast, is actually at and around South Kingstown Town Beach, approaching 1.33 meters per year. And I'll show you what that looks like in a second in a different way. So just extrapolating here on the historic rate, it's already kind of scary. If you go to the low scenario, we're building somewhere back towards Cards Pond Road. And at the high scenario, well, maybe the town should buy that nice undeveloped property next to Blackberry Hill today. So am I running around with my hair on fire on all of these? It's a good question. What I'll say is undoubtedly we're going to get a better understanding of this process as we go through the next few decades. The goal right now of these projections is to do a couple of things, but namely it's to help guide, we hope, sustainable development along the coastline, to help identify areas at risk. The wider the red band, the more dynamic that shoreline has been over the last 75 years and is likely to be more dynamic over the next 75 years. And so our hope is that in these projections, it helps to guide smart decision making. A lot of talk in the communities. I was at one of the community meetings was let's think about reducing density in the coastline, and maybe this can help point to some of those areas to think about reducing density. So if you think I might be running around with my hair on fire, I just urge you to look at a couple of places over not a very long time frame. This is Matunic in 1991, a photograph from the CRMC archives. That's, of course, the ocean mist. That's my friend Jim Torino, I don't know if he's here tonight, likes to remind me that in the 80s and 90s, there was a full-size volleyball court in front of the deck of the ocean mist, and you could reach right up and get your beer without a 20-foot drop. This, of course, building is no longer here. Most of this shoreline protection structure has failed, and it looks a lot different today. Right? And so if we look at the same area taken from a helicopter in August of 2013, you can see where there's no longer really a beach in front of these areas. Essentially, the beach is in front of those protection structures. If we go just around the South Kingstown Beach, again, the highest rates of erosion we've seen on the South Coast, we can see a significant amount of bluff erosion occurring here during a storm event. You can see blocks of the bluff falling down. One of my beach profile colleagues, could be Rachel, for scale in the upper left there in the red dry suits. What does that look like, though? We go out and measure this site. We not anymore. Rob does it now. About every 2 weeks, and we've been doing that since 1996. So we have a pretty good quantitative handle on what this shoreline has done over the last couple of decades. And what we've measured there is almost 30 meters. So basically 100 feet of bluff retreat in 26 years. So this is a very high rate of erosion on that shoreline. So maybe my hair's just singed, but not really on fire on all of these. Okay. If we look at a place like Napattree, where we've seen barrier island migration, again, the red is post-1938. So the migration here has largely occurred during the 44 hurricane, 1954, as well as probably a significant storm down here was the Ash Wednesday storm in 1962, which produced overwash of the barrier here. So we've seen the barrier in Napattree migrate one whole width in 75 years, not in response to any large amount of sea level rise, although we have had a number of storms. If we go look elsewhere, because we don't want to stay too focused in southern New England, there's a great book written by Stan Riggs and a whole bunch of colleagues down in North Carolina about the fate of North Carolina's coastline. We talk about the coast and the ocean driving our economy. It's a different scale in North Carolina. It really drives the eastern half of their state's economy. And if you look at the Outer Banks, first of all, go there now. It is an absolutely stunning place to go. Probably not now. I'd wait till it warms up a little bit, but it is a nice place. They produced a couple of maps in this book. It's all based on scientific literature, but the book figures were nice because they were simplified down for the educated audience. And this is a depiction of North Carolina during the last interglacial period, when its estimated sea level there was approximately 20 feet higher than present. And so just to give you some sense of what it was showing, what this figure is showing, basically the barriers in the shoreline was well inland of its present location. Along the coastal plain, they can actually identify these coastal deposits, get a date on them, and understand when they were formed. Now, you'd ask, well, Bryan, just go do that in Rhode Island. You know, you got nothing better. Well, we, of course, have had a glaciation, and we don't have a record of that higher stand of sea level in southern New England, at least not above present sea level. So we're a little limited in looking at the recent past as an analog for what happened 125,000 years ago. They also had a couple of other figures in here, and they labeled this one North Carolina and the Outer Banks, a couple of decades of sea level rise and a major storm or two. And what you'll notice is the barriers are getting a little more discontinuous. And the breakup of barrier islands and the idea of them crossing a threshold where they begin to migrate faster, there'll still be a barrier in most cases, particularly here, I think, on the glacial deltas we have in New England. But they will probably migrate faster, and there will be a different paradigm we'll be looking at on our coastline. And so I just point you to this one because if we look at this area of the Outer Banks, it looks a lot like that in Google Earth, which happens to look a lot like that, which is, of course, East Beach Barrier. So when possible, we can draw some parallels to other coastlines. I also show you this depiction, and they very well admit that we don't have a great handle on these processes. So this could be 1 or it could be 3 centuries. But this is what they would depict in a very qualitative way, what they envision the Outer Banks of North Carolina looking like in a century or 3. If you notice, there's some remnant islands around Cape Hatteras. A lot of the barriers have retreated back and either drowned and then new ones formed on the other side of Pamlico Bay. But it's a different looking coastline. So it may look like our hair's on fire, but there are a lot of cases where, or a lot of other people thinking about the rapid changes to our coastline. I'll also point out, obviously my last co-author on this presentation was John Boothroyd, who passed away in October of 2015, which would have been fun to have some debates about this projected shoreline change stuff with. This is when you actually really miss them. But we were cleaning out the lab at URI figure which John had made, I'm guessing 30-odd years ago, and that depicts Ninigret. There's East Beach, Charleston Breachway, Charleston Barrier, basically migrating across the lagoon, slamming into parts of Charlestown Moraine and the deltas across the pond in 2500 AP at, I note, only a foot of sea level rise per century. So this is pre-climate change talk, and a retreat rate of a couple of feet a year, about what we're seeing at present. And I will add that that's surprising to see such a low rate of sea level rise. John was actually one of the really early adopters in the 1980s of the idea that sea level was going to change at a more rapid pace. So for those of you that predate GIS, this of course was made on Mylar with Pantone and a Leroy, something we were educating Rob on the other day, back when you had to make figures the hard way and pre-GIS. And so with that, I'll happily take questions if I've got a few minutes, and if not, stay tuned, and we'll be continuing to work on this for the next few months.
How did your methods take into account oral processes, just on average?
The historic rate has basically already taken that into account for us in a lot of ways. We've seen whatever sea level rise we've seen the storms we've seen. And so I don't really love the term statistical approach and process-based approach, because the processes have gone on the whole time that historic rate of change has happened. So that's really the only way. This is not an incredibly detailed sediment transport model of the entire South Coast. That was not the goal. The goal here is to create some planning overlays to guide development, and then we'll continue to refine our understanding and projections in the next, years to decade probably.
Next up, it's me. I'm going to talk about storm tools. We launched storm tools just over a year ago. So I'm going to give you guys an update on where we are with storm tools after I do my little process here of